You're welcome to this class. We are talking about coordinate geometry. In coordinate geometry, there is 2 points whereby we want to analyze. In these 2 points, this is 1 point, this is another point. We want to know the distance between these 2 points. How do you know the distance? If you're able to study this point P, we have x1, y1. In point Q, we have x2, y2. Now, I want to know the difference between them, but they form a triangle, a right angle triangle, whereby we can apply Pythagoras theorem. Pythagoras theorem. Therefore, if you are to apply Pythagoras theorem, you now say that the line PQ squared is equal to line PR squared plus QR squared. Now, how do you know this PR? From this point is x1, this point is x2. That's why we have x2 in this line. At this point, we denote this area, we denote y1. This here we denote y2. So the difference between this will be y2 minus y1. To note if from this 0 to this place is y2, and from this 0 to this place is y1, meaning that this side will be y2 minus y1. So if this is x1 and this is x2, meaning that from here to this place we give you x2 minus x1. Now, to now know the difference between the PQ, whereby you have to apply the Pythagoras, we now continue to have line PQ squared is equal to the line PR. So this is the PR, whereby we have x2 minus x1 squared, now plus the line QR, which is y2 minus y1 squared. So if this is what it brings out, but what exactly thing that we need, it is the line PQ. Line PQ, which will now be the square root of x2 minus x1 plus y2 minus y1. This, what we just wrote, is what we call distance between 2 points. So this is the formula for distance between 2 points. This is how it is being proved. Let's have a very short example of this. Maybe let's have example 1. Let's just have an example said, find the distance between the following pairs of points. Let's say 1, or let's represent by A. We have a point to have A 3, 2. We have another point, which is point B. We have 4, 6. Let's just have to solve 2 questions. We have another point C to have minus 1, 3, and another point to have D, that is 2 minus 7. So if you are to find the distance between them, this point A which is 3, 2, and point B, which is 4, 6. This one will represent x1, y1. The second point will give you x2, y2. So, and you know that the distance between AB, according to the formula that we proved, it let us to know that x2 minus x1 squared plus y2 minus y1 all squared. So you just substitute the formula into it straight. So what is the value of our x2, which is 4, minus, if x2 is 4, x1 is 3, 3 you put square, plus y2, that is 6, minus y1, which is 2, you put square. So in continuation, you now have AB to have the square root of, you go back, 4 minus 3 will give you 1. 6 minus 2 will give you 4. So we have 1 squared plus 4 squared. So if line AB, then the distance between AB will now give you, that is 1 squared will give you 1 plus 16, which is equal to 17. So the distance between AB is equal to root 17. So we still continue for the B part. The second point is a point C, minus 1, 3, 2, and minus 7. So which we write out the point again. The B part, we have C, you write in this form, that is minus 1 and 3, minus 1, 3, and the D point, we go back, is 2 and the minus 7. 2 and minus 7. So now, the CD, the formula is still the same, that is distance between 2 points. To give you x2 minus x1 all squared plus that this is y2 minus y1 all squared. So when you're able to know this formula offhand, it's very easy to just substitute the value. So if you are able to know that the line CD will now be, as you know, this is x1, y1, x2, y2. So our x2 here is 2 minus 1. You put square. Plus our y2, which is minus 7 minus 3. That is y1. You put square. So the line CD will give you, so which is, you have 2 plus 1, you put square, plus minus 10, you put square. I'm trying to explain step by step. So by the time you see any question, it will be very easy for you to solve. The moment you are following the procedure as I'm doing it, it will be so very easy for you also to solve. So this will give you 3 square plus minus 10 square. So you continue to have a line CD. We have a root. So 3 square here will give you 9 plus 100. So we have 9 plus 100. So meaning that the distance between the CD is root 109. So that is just about the distance between two let's explain the distance between 2 points where we're able to solve 2 examples. So the next thing we need to know is the midpoint of a line segment. So if in the midpoint of line segment, this is just the formula, we don't need to waste much of our time in drawing much proving about this. So this is just a formula to get the point. This is just the half of the point 1 of x1 and the point 2 of x2. You just add them together and you divide by 2 in the way to get their midpoint. The same thing applicable to y1 plus y2. So let's take our time to be solving this example one by one. So let's go to the next page. Solution. So the first point is 3, 5. The first point is, that is A. We have the point 3, 5, and the B point is 1, 3. As I've said earlier, the secret behind all this is for any point given to you, the first number here, it is x1. The second number, it is y1. The same thing applicable to here. This is x2, y2, and you're able to have gotten the formula to be x1 plus x2, comma, to the half onto y1 plus y2. So to now get the midpoint of AB. So the midpoint of AB will now be half onto, so our x1 is 3 plus 1. You open a bracket, you comma, onto half onto y1 is 5 plus 3. So that is the midpoint of AB. So you now have 4 over 2, comma, this will be 8 over 2. So the midpoint AB will now be 2, 4. So this is x, this is y. So this is just how to find the midpoint. Let's solve the second example, which is B. We have another point. Point P is -1, 7, and Q -3, -5. So this is just the 2 points. So we apply the formula again, that the midpoint PQ will now be half onto x1 plus x2 onto half onto y1 plus y2. So which we know before that this is x1, y1, x2, y2. So you try to label for you not to make any mistakes in the process. By the time you are labeling it, it's very easy for you to get it. So we have half onto, so our x1 is -1 plus -3, come on to half onto, that is 7 plus -5. So therefore we have half onto this. So this will give you -4, comma, onto half. 7 plus we have 2. So this will now be half onto this. We have -2, comma, this will be 1. So the midpoint of PQ is equal to -2, 1. So the third questions, I will want you to do it as classwork and submit it in a comment section. As you are able to have an opportunity to watch this video, I will also want you to subscribe to the channel. Don't forget to press the red button, subscription, so anytime I'm posting a video, a well explanatory topics like this, it's very easy for you to see. So now we are able to explain the midpoint. Now I want to talk about another subtopic, which is now important, the area exactly we are going to. We call it gradient. Gradient. We all know that gradient of a line is defined as the ratio of increase in y to the increase in x. But before we proceed, let's do a small revision. This is y-axis, x-axis. Just a little revision. As we're able to do the last time, this is P, this is Q. So it was shaded like this. Let's try to have a little dot. So this is also a right angle. Now, as we explained from the beginning that this point is x2, y2. This point is y1, x1, y1. So, meaning that this, if this from here to here is y1, this is y2, meaning that here will be y2 minus y1, as I've explained in the previous one. So, this will be x2 minus x1. Now, as we have defined gradient to be increase in y, the ratio of increase in y to the increase in x. So we just write that. So let's label PQ. Let's represent gradient by M. So our gradient will be, this is just the formula for gradient, QR all over PR. As I've given you the definition as increase in y to the increase in x. So what is increase in y? It is y2 minus y1 over x2 minus x1. This is just the formula for gradient. This is how we find gradient. Nothing else than the best way like this. And also, if you're able to see that you can possess an angle like this, that if you have something like tan theta can be QR again over PR, which is the same thing as y2 minus y1 all over s2 minus x1. So meaning that tan, let's write the next page, that tan theta is equal to gradient, and gradient is equal to y2 minus y1 over x2 minus x1. That is just so. Let's have a short example so we can get it better. Let's say maybe example 1 on gradient. So he said, find the gradient of the line joining 3, 2 and this is another point 7, 10, and the angle of slope of the line. So now, if you're able to see this question, say find the gradient of the line joining, this is the first point, and second point, this is 7, 10, and the angle of the slope. It's so very simple, as I've explained early. You firstly write the point. Let's represent the first point, maybe the point A. We have 3, 2, and the point B, we have 7, 10. As I've explained earlier that to you, that any point written, the first thing there is x. But being the first one, you put 1. The second one is y1. So this one is x2, y2. So if you are now to find the gradient for this, it's so very simple to say that m is equal to y2 minus y1 over s2 minus x1. So let's continue now substituting. So we have 10 to be the y2. Our y1 is 2 minus 2. So we have our x2 is 7 minus, that is 7 minus 3. So making 8 over 4. So therefore our m is equal to 8 over 4, which is equal to 2. That's just a gradient. As simple as that. So the question it continues. It said, and the angle of this, the angle of slope of the line. So let's sketch and see what is happening. This is the point. This is just what it's trying to explain. So this is just it. So very simple. This is the angle it's trying to explain. This is y2 minus y1. This is s2 minus x1. So since we are able to, and you know that tan theta is y2 minus y1 over x2 minus x1. So, and all this, you know that it's equal to 2. So therefore, you now say tan theta is equal to 2. So you now say tan is equal to arc tan 2. So by the time you press your calculator to find the second function of tan theta, our final answer will be 63.4 degree. So this is how we explain. You're able to see that we are able to get the value. This example as well explained, because the point A and the point B, we have gotten the value of m. So our m to be 2 and the tan theta to be 3.4. For better explanatory, let's also find another meaningful example. Let's say example 2. Example 2, maybe in another form. Let's say find the gradient of the line joining. So this is the first point, -3, -5, and this is another point, 4 minus 1, and the angle of the slope of the line. So I just form an example like this. Said, find the gradient of the line joining this point and this point and the angle. We are following the same procedure, but I just want to repeat another example so you can have an opportunity to get it better, because by the time we are now go further, we won't have time to be solving for gradient any longer. Just be applying from our brain. So now, as I've used to say that, let's say the first point is -3 -5, and the second point is 4 onto -1. So our m, which is y2 minus y1 over x2 minus x1, is equal to, so I will not write this now. So I'll just give you what next. So you just have -1 minus -5 over, because this is x2, y2, x1, y1. So our x2 now is 4 minus -3. So the gradient will now give us, so -1. So minus times minus will give you plus, which is this, all over 4 plus 3, which is equal to, so therefore this will give you 4, because by the time you subtract -1 and 5, so this will give you 7. So that is 4 over 7. That's just the gradient, nothing else. So if you're not to find the angle, we all know that tan theta is equal to 7. So theta is equal to second fractions of tan of 7. So the angle we give you, but let's press, if our gradient is, if our gradient is, that is second fractions of 4 over 7, yes, 4 over 7 is, this is 4 over 7. So we have 4 over 7. So tan, it will be second fractions of, so let's find it. 4 over 7 will give you 0.5714. So now the final answer, which is, let me write again, tan theta is equal to 4 over 7. Let's say tan theta will now give you 0.5714. So theta will be the second fractions of 0.5714. So by the time you press calculator for the second function of tan of this, we have our theta to be 29.7 degrees. So that is how we find gradient. Now we want to continue again now to condition for parallelisms and perpendicularity. These two conditions is highly important to know and to notice how they works in coordinate geometry, because we are still going to use it in solving some certain questions. Now, if for parallelism, for example, we must have two gradients. The moment the gradient 1 is equal to gradient 2, that is, it means the two equations are parallel, because it's a line. We are dealing with a line. We want to know it is parallel. So for perpendicularisms, perpendicularity, so it means that by the time you multiply the gradient 1, multiply with the gradient 2, it will give you -1. So we are considering the line. What you are solving is a line. So I'm just summarizing this condition because of our time. Now, that's two conditions. When the first gradient of a line is equal to the second gradient, it means the lines are parallel. If the line multiplied, if the gradient of the first line multiplied with the gradient of second line give you -1, it means the two lines are perpendicular. Let's have a very good example to notice how all this works. Let's just form a question. Determine if AB is parallel or perpendicular to PQ in each of the following. So I'll be choosing it one by one now. Let's say I want to solve for A now. A, I was given the fixed point that is 3, 1. The B, that is 4, 3. We have P to be 4, 6, and the Q to have a 5, 8. We have to consider we want to know maybe AB is parallel to PQ or AB is perpendicular to PQ. How do you know this? The first thing you need to do is to find the gradient of the AB. What is the gradient of the AB? That is, so let's represent that M, the M1 of AB will be, that is Y2, that is X1, Y1 will go back again, that is X2, Y2, that is just give you 3. For the AB, you have 3 minus 1 all over 4 minus 3. So this one will give you 2 over 1, which is equal to 2. So M1 is equal to 2. So now let's find for the second one, which is for PQ, that is M2 of PQ, which will give you 8 minus 6 all over 5 minus 4. Let's see what it give you. This will give you 2 over 1, which is equal to 2. If you notice now, you discover that M1 is equal to M2. That is gradient 1 is equal to gradient 2, meaning that AB, the line AB is parallel to line PQ. So these two lines are parallel. That is just the meaning of what we are solving. The two lines are parallel. So let's also consider another example. So for you to get it better, let me explain. So we are dealing with this statement that determine if AB is parallel or perpendicular to PQ in each of the following. We have solved for A. Let's now solve for B. So this is the B question. We have point A to be 5 minus 1. Point B to be 3, 2. So we have P to be 2, 4. And point Q to be 5, 6. So now our M1, which is just denote like M1, that is AB. For you to get it better, so it will be Y2. You don't need to waste much of our time. That the Y2, that should give you 2 minus 1, because our Y2 is 2, Y1 is minus 1. So our X2 is 3 minus 5. So which will give us, this is 2 plus 1 over minus 2. So which means that M1 is equal to 3 over 2. So let's find the M2. So M2 we deal about the PQ. So which is equal to our PQ. Our Y2 is 6. Our Y1 is minus 4. So our X2 is 5. Our X1 is minus 2. So this will give you 2 all over 3. So we want to consider maybe it is parallel or perpendicular. So if this one is 3 over minus 2. So this one is 2 over 3, because it's meaning that M1 is not equal to M2. So let's consider maybe M1 multiplied by M2 will be minus 1. Let's see. So our M1 is minus 3 over 2 times, let's see, it is 3 over minus 2 times 2 over 3. So this one cancel this cancel this. It gives us minus 1, meaning that in this equation, AB is perpendicular to PQ. How and why? Because you multiply the value of M1, that is gradient 1, you multiply the gradient 2, it gives you minus 1, showing to you that AB is perpendicular to PQ. That is how, because from our explanation from the beginning, and the definition of this condition, we said for parallelisms, M1 must be equal to M2. For perpendicularity, the multiplication of M1, when you multiply with the M2, will give you -1. So in the second part of the example, which is B, we discover that the line AB is perpendicular to line PQ. Let's just solve one more to get it better, so to know how the condition of perpendicularity and the parallelisms work. Let's assume we have A to have 4, 7. We have B to have 6, 8. Let's see, maybe it's not the same thing I'm reasoning. Okay, yeah, good. So therefore, we have 4, 7, B is 6, 8. We have PQ. So our P now is 3, 5. Our Q is 5, 6. That is a 3, 5, 5, 6. That is 6, 8, and the 4, 7. So now let's find the M1. Our M1 will be 8 minus 7. That is our M1 over 6 minus 4, which is equal to 1 over 2. Let's find our M2. Our M2 for PQ will now be divided. That is 6 minus 5 over, that is 5 minus 3. So this one will give you, this will now be 1 over 2. By the time you discover that M1 is half, M2, it is also half, meaning that M1 is equal to M2. So for this equation, as you see it, it means that the line AB is parallel to line PQ. That is how we consider them. That's how we get out its move. Let me just solve one more. So to be the last example, the reason I'm solving this for the perpendicularity, I want you to get it better, because we are using the perpendicularities and parallelism to solve many advanced questions, both in WAEC, JAMB, in higher institution. So this perpendicularity and parallelism conditions and principles is what we exactly that we need in solving the equation of a line in coordinate geometry. So let's find this at this spot now. So if you are to find this, you have to consider finding the gradient. Our M1, which is Y2 minus 3 minus, that is minus 3 minus 2 all over. We are considering the AB now. AB, that is 2 minus 1. So this one gives us minus 3 plus 2 all over 2 plus 3. So M1, which is, you're able to know, so to get it better, so we have minus 1 over 5. So let's find the M2, which the one that dealing with the PQ, which is the Y2 minus Y1. We have a 7. We have 7. That is 7 minus 4. So we have, sorry, this one is 2 plus, this one is 2 plus 1. Sorry, 2 plus 1 to give us 3. Just notice, so 2 plus 1. So this one will give you, 3. So this is 3. Now, so 7 minus 4 all over, so it will be 6 minus 5. That is 6 minus 5, which is equal to, this is 7. We have 3 over 1. So let's multiply M1 to multiply M2. Let's see what it gives you. So it gives us minus 1 over 3 times 3 over 1. This cancel this, give us minus 1. Meaning that the line AB of this equation is perpendicular to line PQ. Please, as you are gaining this, I also want you to do something for this channel. Please help us to subscribe. So at least subscribe. After you've been watched, share to the people, so they're able to solve many questions in WAEC, NECO, JAMB, and any external exam like SAS, Saheb in America. So we continue more of this. We want to talk about the equation of a line. In the equation of a line, let's just have a little sketch like this. This is y-axis. This is z-axis. As this line is moving, this line PQ is moving, it intercepts at this point. Where it intercepts in this one, so why reach this point? So what you just, if you have to find the gradient at these junctions, you discover that this is x. You said our gradient is y minus constant over x. Let's cross multiply. We have ms is equal to y minus c. Let's say y minus c is equal to mx. Therefore, y is equal to mx plus c. This is the equation of a straight line. This is exactly that what we need. This is what I explained. This one is a gradient. This one is an intercept. This is y-axis. This is x-axis. Let's have a meaningful example. He said, determine the equations of the following line in gradient intercept form and sketch each of them. We have a gradient. You will be given a gradient. The first solution of A, we have been given a gradient to be m is equal to 3 and c is equal to 2. And you all know that y is equal to mx plus c. What you just need, you just substitute immediately. We have y is equal to 3x plus 2. Now, if you now want to sketch this, what you just have to sketch from this is that you have something like this. You have something like this. So it intercepts y at exactly 2. So this is x, this is y. This is just the sketch that it needs. Y is 3x plus 2. This is the intercept. It's shown here, the c part. So let's solve the second one, b, which says the gradient is minus 2 and the intercept is 3. And you know that the equation of a straight line is ms plus c, whereby y is equal to minus 2x plus 3. So if you have to sketch this, you just discover that your sketching will be in this form. After you go further, you see that it has a plus 3. Can you see now? So the intercept is plus 3. So this is just the equation. So this is sketching for this is x-axis. This is y-axis. So let me solve the third one. The third one says m is plus 4 and the intercept is minus 1. So let's solve this. So we have c, where m is equal to, from the questions, he said our gradient is plus 4 and the intercept is minus 1. So plus 4 and c is minus 1, which we know that mx plus c, that is the equation of the line. The only thing you just need at this junction, you just substitute, whereby y is equal to 4x minus 1. So in case you have to sketch this, what you just have to sketch is so simple. You just have to sketch something like this because it moves to minus 1. Can you see it now? So this is minus 1. So this is this is y-axis. This is x-axis. So this is how it moves. So this is the equation of a straight line. Now, in a way to get you two can able to deduce your own personal, let's have another example that will give you another inspiration. Said, find the gradients and intercepts on the y-axis of the following lines. So now let's say we have some line like y is equal to 3x minus 4. We have another line like y is equal to minus 5x plus 1. Let's say we have another line c, y is equal to minus half x minus 3. So now, in a way to find this solution, let's have meaningful things to do. Let's have solution. So A if you are to find the gradient and intercept of A, if y is equal to 3x minus 4, meaning that our m, which is the gradient, is 3, and our intercept, that is c, is equal to minus 4. So simple as that. Like this, the B part says that y is equal to minus 5x plus 1. You all know that whereby our mx plus c, meaning that our m is equal to minus 5 and c is equal to 1. That is just how to find it. So I will want you to tell me the value for the gradient here in the class. This is a classwork. You send it to me in the comment sections. So you tell me the gradient and the intercept. Now we are now going to the exactly area where it is somehow important to know better. We want to find the equations of a line. We have many conditions for it. The equation of a line when the gradient and 1 point form. When we have a gradient and 1 point, what do you mean by that? For example, we have a point like point A, x1, y1, and the gradient. So simple as that. So what do you mean by that? It means that I want to find the equation. You say y minus y1 onto x minus x1 is equal to the gradient. This is just the formula for this condition. When we are given a condition of a gradient and 1 point, it means that y minus y1 over x minus x1 is equal to the gradient. Let's have a kind of a little illustration or an example. Maybe somebody says that find the equation of a straight line of slope 2. You know, slope also means gradient. Slope 2. If it passes through the point 3 minus 2. So this is exactly what I'm explaining right now. If you're able to see this equation, they are telling us that we have just a point, let's say point A, which is 3 onto minus 2, and we have a slope, which is what we call gradient. How do we find the equation for this? For a point and a gradient, we all know that the formula is given in this form, that y minus y1 over x minus x1 is equal to the gradient. From the point given, you know that this is x1, this is y1. So if this is x1 and this is y1, therefore, you now say that y minus 2, because that is the y1, over x minus 3 is equal to the slope, which is the gradient, which is equal to 2. So in continuations, to find this, you continue to have y plus 2. So this one is y plus 2 onto x minus 3 over x minus 3 is equal to 2. So y plus 2 is equal to, you cross multiply, we have 2 onto x minus 3. So making y plus 2 is equal to 2x minus 3. So therefore, we try to collect the like terms. We have y is equal to 2x minus 3 minus 2. So by the time we have this, this is 2 times 3 will give us 6. So this one will be 6 at this junction. So this will be 6. So 2 times we have 6. We have 6. So meaning that y is equal to 2x minus 8. So this is just the equation. Let me re-explain. You know, this is y plus 2, x minus 3 onto 2. You cross multiply. We have y plus 2 is equal to 2 brackets x minus 3. So y plus 2 is equal to 2 times s. We have 2s. 2 times minus 3. We have minus 6. So therefore, we collect the like terms, we shift these 2 to this side. That is what we have, 2x minus 6. Now the positive side we change to minus. We have minus 2. This is just the equation. So we have another conditions that when we have 2 points, the 2 points, the equation of a line when it is condition for 2 points, 2-point form. 2-point form. For this condition, let's bring a formula for this. What they're just trying to explain here is that it's meaning that y minus y1 over x minus x1, that you just have to find your gradient by yourself, which is y2 minus y1 over x2 minus x1. So for you to get this point, let's have the example in the 2-point form. So let's solve the, the first point is P, which is 2. X is 2, y is minus 3, and x is minus 4 at the point Q, and y is 2. So you know that since it has been written in this form, as I've said earlier, that any point being given, x and y are the point. So therefore, it said find the equations of the straight line which passes through the point this, and this is the first thing you do. You find the gradient. We all know that the formula for gradient is y2 minus y1 over x2 minus x1, and we are able to have gotten the value of y2 to be 2 minus 3 all over minus 4 minus 2. So our gradient here will give you 2 plus 3 all over minus 6, which will be 5 over minus 6. So the next thing you do, because it's a 2-point form, so in process, meaning that y minus y1 over x minus x1, the real formula for this is y2 minus y1 over x2 minus x1. And since we're able to have gotten the value of y2 minus y1 onto x2 minus x1, which is 5 all over minus 6. So what next for you to write is 5 all over minus 6. So therefore, we continue from here that our first point is 2 and minus 3. So that is the first point. That is, we now have y minus, recall that our y1 is minus 3. So therefore, minus 3 all over x minus, what is our x1 from our analysis is 2. So our x1 is 2, which is equal to 5 all over minus 6. So now it's just y plus 3 all over x minus 2 is equal to 5 all over minus 6. Therefore, by the time you cross multiply minus 6 onto y plus 3 is equal to 5 onto x minus 2. Let's expand. Minus 6y minus 18 is equal to 5x minus 10. So what do we do? Because we need to make the y. So let's just have, that is 6y. We have minus 18 plus 10 is equal to 5x. Let's just try to put, let's say minus 5x is equal to 6y. So therefore, 6y equal to, so this is minus 5x. So by the time you add 18 plus, minus 18 plus 10 will give you minus 8. So therefore, let's divide all through by 6. So therefore, we have y is equal to minus 5x all over 6 minus 8 over 6. So you can, so minus 5x over 6. So what next you can able to do that to get your final answer? You said y is equal to minus 5x over 6 minus, let's reduce here by 2, 4 over 3. So that is how we find the equation for the second, the 2-point forms. So the solution for this, for the 2-point forms, this is how we do it. So now we go to what we call a perpendicular distance from origin. He said P is equal to S cos alpha plus Y cos Y sin alpha is the equation of the line where P is the perpendicular distance. This is just the formula you just have to apply. He said find the equations of the straight line whose perpendicular distance from the origins of the length 2 units and its angle of 30 degrees to the positive axis. Let's just have a small sketch. Like this is y-axis, x-axis. This is the point they are talking about, the 2 units, and this is 30 degrees to make it to be perpendicular. So therefore, let's now put to get the value of the real equations. You now have what's the value of our P? It is 2 equal to, it is 2, which is equal to x cos 30 plus y sin 30. So making 2 onto x. What is cos 30? Cos 30, you are in a third form, we give all 3 root 2, root 3 over 2, plus what is cos y? Sin 30 is half, that is over 2. So we just have to get, therefore the real equation will be 2 is equal to x root 3 over 2 plus y over 2. This is just the real equations. This is how to find this in case you are given the perpendicular distance from the origin. So this just have to apply this formula. So next we do is there is something we call a general form. This general form, there is a way we solve its own personal problems, questions. He said, let's have an example 1 on general form. Find the equations of the straight line which passes through the point minus 3, 5 and is perpendicular to the line 2x minus 4y plus 3 is equal to 0. Remember, there is a statement uttered here. It said perpendicular. That is, if it is perpendicular, there is something we have to do to make it to get the original, the accurate answer. But don't forget once again, if you have never subscribed since you have been watching this video, I want you to click the red button to subscribe to this channel so to gain better. So therefore, we have 2x minus 4y plus 3 is equal to 0. The first thing you do, you make the value of y plus 3 is equal to 4y. Let's all divide all through by 4. So we have y is equal to 2x over 4 plus 3 over 4, which is equal to x over 2 plus 3 over 4. So that's the value of y. If our y is equal to x over 2 plus 3 over 4, meaning that our m1 is equal to 1 over 2. But there is a question here. It says, if this point is perpendicular to this line, therefore, I've talked about the perpendicularity and parallelisms, that m1, by the time multiply m2, it must be minus 1. And we have been given from this, we need the value of m2 now. So we have been given the value of m1 to be 1 over 2 times m2, which is equal to minus 1. So therefore, what we need here is you find the value of m2 to be minus 2. So if our m2 is minus 2, and you know that m is mx plus c, and you have been able to get a value of the m is equal to minus 2x plus c. But the point given, this is the point given, minus 3 and 5. Remember, he said through the point this, and is perpendicular to the line. So you go back to the point whereby our x is 3 and y is 5. So we have 5 is equal to minus 2x. Minus 2, you're able to know the value of x at this point. So our value of x is minus 3 plus c. We want to get the value of the intercept. We have 5 is equal to 6 plus c. Therefore, c equal to 5 minus 6. So our c is equal to minus 1. So if our c is equal to minus 1, and you know that our m2 here is minus 2 and c is equal to minus 1, and the equation of a line is mx plus c. So you just have to substitute the value whereby m is equal to minus 2x minus 1. So this is it, meaning that this line is perpendicular to this line. That is just the meaning. So this point will make you to know we have solved the one that have the perpendicularity condition. Let's also solve in general form the one that have the parallelisms. Let's see the second example. It says this second example, it says find the equations of the straight line which passes through this point, the same point, and parallel to the line. You have to follow the same procedure to solve the questions, which is you make y to be the subject of the formula. We have 5x minus 2. So what do you do next? You divide all through by 3 to have y is equal to 5x over 3 minus 2 over 3. So since we are able to divide that, which we have y is equal to 5x over 3, if our 5x over 3 minus 2 over 3 from what we got from by the time you divide all through by 3. So therefore, meaning that our m1 is equal to 5 over 3. But the condition let us to know that it is parallel, that the line 1 is parallel to line 2. So meaning that the m1 must be equal to the m2. So we are able to get the value of m2 to be 5 over 3 because of the conditions of the parallelisms. Therefore, when we are having a point, our points given from the question, minus 3 and 5. So we have minus 3 and 5. So therefore, we use these two variables to get the value of the intercept. Therefore, we have y is equal to mx plus c. Now, if the y is mx plus c, we are able to get the value of our y to be 5, which is equal to, and our m2 is 5 over 3, and our x is minus 3. Now, plus c. It is covered that this we cancel this. 5 is equal to minus 5 plus c. So if it is minus 5 plus c, meaning that you make c to be the subject of the formula, therefore c is equal to 10. Now, if c is equal to 10 and you're able to get the value of the gradient, which is m2, and our formula to find the equation of a line is this. So our y is equal to what is the value of m, which is 5 over 3. That is 5 over 3x plus 10. That is the value of that. That is the value of the intercept. So what you do here, you try to multiply all through by 3 to make the equation. This equation is not all linear. To make all the equation to be linear, so we have 3y is equal to 5x plus 10. So that is just the answer for these questions. So that is how we solve it. So thank you for watching this. So don't forget to subscribe to the channel.